Hello. Hi everyone, my name is Chedeau, and I'm also known as Visual on the internet. And today I'm super excited to be here, like at the third React conference. And like, if 2 years ago you told me that there would be like a React conference, I would not have believed you. So I think one in Salt Lake City with all of you, like this is like blowing my mind. But anyway, so I'm working on React Native, and the goal of this project is to implement high-quality mobile apps that are indistinguishable from native apps. And we're using React to build this. And one of the main changes that we faced is that most of the mobile apps, they're mainly like gesture-driven with animations. And what we found out is like React has not been designed for this. And like very few people actually wrote animation using React. And so today I'm going to explain you how we went on like trying to implement those. So before we do that, I'm going to show you like a few examples of animation we've been able to make. So the first one is the F8 app. So this is a conference app like this one. And you can see like the header on the left, like they push each other. Like there's a smooth animation when you open. Like there's a scroll view, like you can animate while dismissing. And so all of this is written in JavaScript. And here, if you can see, like the curve is actually animating. And there's a smooth like popover that's coming in. Like there's animation when you transition in, out. And so this is like the first thing. Then one of the projects I worked on is an image gallery on the web, and I couldn't make it work. And so this was like one of the big tests of React Native, and we actually managed to implement like a really smooth image gallery using React Native. And so you can see like you got like transition, rotation, like it smoothly moves like this. And finally, some kind of animation that are harder to implement on the web, like, oh, I want to animate everything, like text animating, like everything's coming, text is coming in. And so those are the kind of animation that you can implement using React Native. And those are the kind of animation that you see in like the Facebook apps or like normal native apps. And so today I'm not going to talk to you about how to implement those animations, but instead I'm going to explain to you how we get those animations to be performant. And so for this, I'm going to explain to you 5 techniques that we used. So the last one is going to be the one we actually ended up using, and it's a bit of a secret technique. So I'm going to focus on only one example, which is just an element sliding in your viewport. So the way you implement this using React, like if you follow the tutorial, you're first going to set your progress of the animation using in the state. Then you're going to use inline styles in order to like update the left style. And then on the request animation frame, you're going to set state the left instance variable and to update. And so this is going to work. Like you're going to have an animation. But now let's look at the performance characteristic of this. So you're going to set state on this node, and it's going to re-render this node. But the way React works by default is that you're also going to re-render the entire subtree. And so this may sound like a crazy default, because this is not this sounds like not optimized. But what we found out is in practice, like this is like most of your use cases, like they do not need like high performance. And this is a really good default because it doesn't add many constraints to you. And so what we're going to see is in order to improve the performance, we're going to add constraints to the developer. And so we want to only add constraints where you're on the critical path or you are, and you have like some performance issues. So now let's assume that it takes more than 16 milliseconds to re-render this entire tree. So if you keep following the React documentation, the suggestion that we give you is to implement should component update. So it's a hook that given the previous props in state and the next prop in state, you can tell React like, okay, React, I'm confident that nothing is going to change. like just keep re-rendering this part. And so this is actually a very good technique, and with like most of the performance issues I've seen people have with React in the past 3 years have been fixed using should component update. But it's not like it's a bit impractical to implement in practice because you're not working alone on your project, and usually the way you split up your project is that each component is owned by someone. So if you want to animate the top component, you basically own it. And so all of the children, they're owned by someone else. And now, if you want to implement should component updates on an element, you need to refactor it a bit. So you need to use immutable data structures, not use bound functions, and like something like this. And while like most of the time this is not a big refactor, this is still like modifying this code. And so now we break one of the like big characteristic of React, which is isolation. When you want to animate the top component, you should not have to modify the other components. And so this breaks these assumptions. And so if you had a magic wand to fix this problem, what you would likely do is want to move the should component update decision up in the parent. And so if you do that, then if you animate the top component, then you're now responsible to make sure the children are not being re-rendered. And so the way to implement, there's actually a way to implement this using React in a module with a component that we call static container. And so the way you use it is you wrap your expensive child in a static container with a prop called should update that says, oh, I'm not animating. So if I'm animating, I don't want any child to re-render because I don't want to drop a frame. And so the way to implement this is fairly trivial. You just create a React component. You just forward all the children that have been passed. And then in should component update, you just give the should update prop. And so using this technique, you're able to control when the child component gets re-rendered. And so this is one way to do it, but there's actually another way to achieve the same effect using React. And this is called element caching. So in order to understand what this technique is, we need to understand what is an element. So a React element is anything returned by JSX, by a JSX type. And if you're not using JSX, you can use React.createElement to return it. And so React has an optimization inside that says that when it's going to diff two elements, if it's exactly the same element, like triple equal the same element, then it's going to bail. It's going to say like, okay, this element didn't change, I'm going to not re-render it. And so the way to use this technique is by caching the element in the instance variable like this, and then you're able to like control when this child gets re-rendered. And so those two techniques are very useful to improve the performance of your app, but they are not silver bullets. And one of the big issues that they have in common is that they add a new bug that disappeared from React, which is race conditions. So one of the bugs that can happen in this case is, let's say there's an update that comes in while you're animating. This means that the animation is going to say like, no, I don't want to re-render this child element. And then the animation finishes. And if you don't re-render, then you're going to have dropped this update. And then you're going to like have some inconsistent state. And if if this component like re-renders sometime in the future, then your updated version is going to pop in from nowhere. And it's going to be a bad experience for the user. And so now if you look at this technique, what we are trying to do is to like say, React, like I don't want you to control the diff algorithm. Like I know better than you. I want to do my own thing. And so when you think about it, the only thing that we want to change here is the left attribute. And so we don't want to re-render the entire like component and the children. Like we just want to set this one value. And so there's actually a way to tell React like to do that, which is by implementing row DOM mutations. So we're going to get outside of React's diffing algorithm and world, and we're going to say like, React, I know what I'm doing. Give me the real DOM node I'm going to use, like .style.left equal to 10px. And so the way you implement this is actually pretty trivial. On your onUpdate, instead of doing set state, you're going to do react.findDOM node this .style.left equal to value plus pixel because of CSS. And so this is going to be like the most performance thing you can do. Like you're doing like row DOM mutation and like you get all the performance that you want. But unfortunately, the same way as the other technique, it has some big downsides. And the big one with this technique is that you're going to have to deal with undefined values. Because if the component gets unmounted from the DOM, then the DOM element doesn't exist anymore. And so now you're going to try to set the style on an element that doesn't exist anymore. It's going to throw an exception. And we've got like so many of those in React Native. Like this is not ideal. And also like we're still not we still have many race conditions that can happen. Because on one side, there's a normal React rendering that has a value for the left, but you also inject on every animation frame a value for the left. And now, if any of those two are do not want to update the value to the same value, then you're going to have a race condition on who gets in first. And so this is like those techniques are very useful, but they have like some like big trade-offs. And one thing that I really hate about those is the reason why I went into React in the first place is because it eliminated all of those race conditions and like state management bugs that you had in like previous application. And now if you want to have high performance React application, like you need to go back to all of those like bugs and like fight with them again, which is not an ideal solution. So I wanted to see if we could find a way to get the best of both worlds. The row DOM mutation like performance and also like all the safety benefits of React. And so I went back to the first example and looked at it and stared at it and I was like, okay. So actually what I'm giving to React is I say that the div style and left equals to this.style.left. So why is React not able to, whenever I update this.style.left, just update this attribute? Why does it have to do an entire diff algorithm and regenerate a lot of things? So what I would really like to do is for React to remember that this.style.left is equal to div.style.left. And whenever I set states, I'm going to like output a row DOM mutation. And so before we go to the next slide, I want to take a moment and to forget everything you know about React. And I want you to keep an open mind. Because this technique actually has a name. It's called data binding. And so you may be wondering, like, why am I here today and talking to you about React, about data binding when Pete Hunt, like a year ago, went on stage and said, like, the reason why we use React is because data binding sucks, basically. And so before, like, in order to answer this question, we need to figure out, like, what are the performance considerations of data binding? So in order to do data binding, for every binding that you have in your app, you're going to have to allocate some object. So it's going to take some memory, and you're going to like have to allocate this object. So you're going to like initialize it and take some CPU to do it. But you're going to get really high performance updates. You're going to get O of 1 updates. And so what Pete was talking about is using data binding for user interface, like for the bulk of your UI. And so this is actually not a good fit, because in a typical UI, your model is going to be much bigger than your view. Like, you're going to pre-cache some other pages. You're going to have a lot of things that you're going to not display. And because you're going to have a data binding element, like a binding element for every single model element that you have, it's going to cost a lot of memory. And also, data binding is optimized when you just have a simple mutation on a single attribute or value or something like this. But this is not the usual workload for most apps. For most apps, like, the app is static, or maybe like on Facebook, like the like count is going to change, but most of it is static. And then the next time you change something, you're just going to navigate somewhere else and like tear down the entire view and create a new one. And so with this workload, like, startup time matters a lot. Like, when the user goes to facebook.com, like, you want something to be displayed on the screen like as fast as possible, and when you click somewhere, you want to change as fast as possible, and you don't have the time to set up all of those bindings. And so for user interfaces, data binding is actually not a good fit, and the React model is actually much more efficient for this. But then when you look at animations, you have only a few attributes that you want to animate. You only animate like a few elements. And when you animate, you only animate like the left, the top position, maybe a scale or opacity, but that's it. And the trade-off that we want is we want the absolutely best performance for every single frame. Like, we cannot go past 16 milliseconds because we left the train, like the train goes and like we lost a frame. And so it's much more important than startup time. But even in this case, like, startup time to allocate like dozens of bindings, like, this is like pretty cheap. And so data binding for animation is actually a very good solution. So now let's see how to actually implement data binding using React. So the first thing that we want to do is to not use a normal div, because React doesn't know about data binding, and if you use a normal div, like, you won't have data binding. So what we want to do is to create a new component that looks and feels like a div, but has this data binding ability. And so in the animated library that we use in React Native, we just call it animated.div. And the second thing that we need to change is we cannot use an initial state which is a state which is just a number, because in JavaScript, you cannot tell when just a number changes. What you need is to wrap this number into a binding. And so in animated, it's called animated value. And then when you have this binding, then you can set the value on this binding, and it's going to propagate somehow to the DOM. So let's see how to implement this propagation. So the first thing we want to do is to create a div element that just looks like a div. And so for this, you can just create a component that renders a div and just forwards all the props. And so now let's see how to actually implement the binding. So on component will receive props, we're going to look at the left style, which is a binding, and we're going to register a change listener. And whenever this value changes, we want to find the DOM node and do a raw DOM mutation. So we get this very fast update. But if you implement it like this, then you're going to leak memory. Because every time you're going to re-render, you're going to allocate new binding that are doing exactly the same thing. And if the component unmounts, like, the bindings are still going to be there, and you're like, it's still going to be not ideal. So React is actually very good because it provides you all of those lifecycle methods that tells you like when a component has been updated, when it unmounts. And so using those, we can remove the previous listeners before we receive the next props and before we unmount. And so thanks to this, we're able to solve all of the race conditions, all of the memory leaks. Like, we don't need to care about it. Like, anytime the component is unmounted, then the binding is going to know that it has one less element to be animating. And when it goes down to 0, we can even stop the current animation. And so using this, it gets us all the reliability of React. And so this almost worked, but we need to do one more thing, which is that if you just pass animating binding to React, it doesn't know what to do with it. I don't know what to do with an object as a style attribute. So what we need to do is to implement, mangle the props and find all of the bindings and just replace them with a real value and store it somewhere. And in render, we're going to render those so that the div element of React actually knows how to work with them. And so this is just a dummy example of how to do it. And as you can see, we're actually doing some work. We are allocating new objects, we are doing some bindings, but you're only going to do this work at startup time, and then you're going to get very, very fast updates. So I've explained to you 5 of those techniques, and those techniques are not limited to animations. In your app, you may have performance bottleneck, and I highly encourage you to use one of those. And one of the great things about React is that it provides this diff algorithm by default. And this is very good for the most of your use cases. But if you want to implement a different update strategy, like raw mutation, data binding, or static container or whatever, you are able to do that. And I think this is one of the best parts of React, and why I'm so excited about the project is because it gives you the versatility to do all of those. And all of those updates are actually scoped into a component. So you write all of this crazy stuff in this component, and then from the outside world of React, it just behaves like a normal component, and you have no idea if it's simply using the normal rendering strategy or some crazy stuff. And I'm so thankful for React for being as versatile. So thank you very much.